Students, our today topic is coordinate compound and organometallic. First of all, we are doing coordinate compound. These are the compound which contain a central atoms or the ion surrounded by a number of opposite charged ions or neutral molecule while on their normal valency. For examples, there is cobalt is central atom or NH3 and Cl is the surrounding molecules on opposite charge ion. Here NH3 is neutral molecule and Cl chlorine is negative charge ions. Cobalt, the central atom or the ion NH3 is neutral ligand and Cl is negative ligand. Students, now we are doing the coordination numbers. In this example, the coordination number is 6. It is equal to total number of ligand attached to the central atom. In this example, cobalt is central atom and there is attached three ligands of neutral ligand NH3 and 3 ligand of negative charge ligand chlorine. 3 plus 3 is equal to 6. So it is coordinate number is 6. Students, now we are doing learn about the oxidation number of central metal ions. This is equal to charge on the metal ion. We are doing this with the example. For example, in this example, oxidation number of cobalt, let it is equal to x, and amine's oxidation number, it is neutral, is equal to 0 and chlorine is equal to -1, and oxidation number of cobalt is equal to x plus 3 into 0 plus 3 into -1, it is equal to 0. On solving this, we get x minus 3 equal to 0 and x equal to 3. So oxidation number of central metal cobalt is 3. Students, now we are doing oxidation number with another example. In this example, let cobalt has oxidation number x, ethylene diamine has oxidation number 0, and amine have oxidation number 0. Now oxidation number of cobalt is equal to x plus 3 into 0, 2 into 0 plus 3. 3 is from this. Now on solving this, we get x is equal to 3. So oxidation number of cobalt of central atom is 3. Students, now we are doing oxidation number with another examples. In this example, let nickel has oxidation number x and carbonyl ligands has oxidation number 0. So we get x plus 4 into 0 is equal to 0. So oxidation number of nickel is 0. Now we are doing with another example. In this example, pyrite let has oxidation number x, cyanate has oxidation number -1, and we get x plus 6 into -1 it is equal to -4. -4 is from there. Now on solving this, we get x minus 6 is equal to -4. On solving this, we get x is equal to -4 plus 6 is equal to 2. Now the oxidation number of pyrite is 2. Students, now we are doing the IUPAC name of the coordinate compound. The first example is K3CONO2 6. Its name is potassium hexanitrocobaltate 3. We name according to as first name of positive K3 potassium, then its name of coordinate complex. The coordinate complex first name is ligands according to their alphabet, then name of the metal ions, then add 8. Now the second example is K2Al aluminium C2O4 3, and its name is potassium trioxalate aluminate 3. The name we are take first of all, first part positive, then negative. The positive part's name is potassium, then coordinate complex name is as first of name ligands trioxalate, then ligand name of the metal atom aluminate, then plus 8 plus 3 is oxidation number of aluminium. Students, now next example is CrH2O5Cl Cl2. Its name is penta aqua chlorochromium 3 chloride. Now its name is according to first positive parts, then negative part. Positive part is coordinate complex. Its name is according to first ligand, their alphabetic order. Aqua name is first, then chlorine. So its name is penta aqua, chloro, chromium. 3 is oxidation numbers, then chloride. Now there is a next example. In this example, there is COEN2NH32Cl3. Its name is diamine with ethylene diamine cobalt 3 chloride. In these examples, we take first positive part, then negative part. Positive part is coordinate complex. Its name is according to their alphabetic order of ligands. According to their alphabetic order, A come first and E second. Then we names diamine with ethylene diamines. Then name of the metalline is cobalt. This is oxidation number. Then it is named chloride. Student, next example is Ni nickel CN4 2 negative ions. Its name is tetracyanoniclate 2 ions. This is the only negative part, so its name as first ligands tetracyano, then name of metal nickel plus 8 plus oxidation number 2 ions. Now the next example is NaAlF6. Now its name is sodium hexafluoroaluminate 3. Now its name is first part of positive parts, then negative parts. Positive parts is sodium, then name of coordinate complex is hexafluoroaluminium plus 8 plus oxidation number 3. Now the next example is AgNH32Cl. Its name is diamine silver 1 chloride. Now first name is positive parts, then negative part. First positive part is coordinate complex, then first name is ligands diamines, then name of the ligand silver. Now oxidation number 1 and the name of the negative part chloride. The next example is CuNH3 4 SO4, then its name is tetraamine copper 2 sulfates. Now first name is part positive parts. Positive part is coordinate complex and its name is tetraamines, name of ligands, then name of metal copper 2. Now negative part sulfate. Students, next topic is isomerism. First, ionization isomerism, the compound which have the same molecular formula but give different ions in the solution. For example, in these coordinate compounds gave outside ion is bromine, and in this example coordinates compound gave sulfate ion. Both thus have same molecular formula but gave different ion in solution. This gave bromine ion or this gave sulfate ion. Students, next isomerism is hydrated isomerism. The isomer differ in the number of water molecule present as a ligand. For example, in this example, aqueous molecule of water is present in coordinate complex, and in this coordinate complex is no water molecule, and water molecule is outside the coordinate complex. These both the equations, both the examples, the molecule formula is same but the difference in number of water molecule. Student, next isomerism is geometrical isomerism. In this isomerism, due to different position of ligand either adjacent to each other, synform, or opposite to each other, transform around the central ions in the complex, two geometrical isomerism exist. Students, we are doing geometrical isomerism with this example. This is diamine dichloroplatinum 2 coordinate compound. In the cis form it is as platinum metal atom and 2 chlorine ligands on the adjacent side and 2 amine ligand as adjacent side, so its name is cis diamine dichloroplatinum 2. This is square planar complex pore since there is a 4 ligands. Now we are doing this with a transform. In this example we take platinum metal ion is centers and chlorine 2 ligands on the opposite sides, and similarly amines on the opposite side, so its name is trans diamine dichloroplatinum 2. It is also square planar complex, has coordinate number 4. Students, now we are doing the geometrical isomerism with another example, octahedral complex tetraamine dichlorocobalt 3 ions in which coordinate number is 6. In the cis form, we take amine ligands on the adjacent side. There is a 4 amines, then chlorine on same adjacent sides, so its name is cis tetraamine dichlorocobalt 3 ions. Since there is a amines as well as chlorine ligands on the adjacent side. Now we are taking ligands on the opposite sides, chlorine on the chlorine on the opposite side and amines also on the opposite side, and so its name is trans tetramine dichlorocobalt 3 ion. Students, next isomerism is optical isomerism. The two isomers which rotate the plane of polarized light toward the left and the right equally and are related to each other as an object to its image in mirror. This is called optical isomerism. For examples, there is an example of diamine dichloro, ethylene diamine cobalt ion. In this, there is a in optical isomerism, both D and L, there is mirror image of each others. So these are called optical isomerism. Students, today topic is complete. Thanks.